Hola, mathematicians. Today, for lesson 1-3, we are reading, writing, and converting decimals to fractions. That is right, fractions, the F word of mathematics. So let's talk about what is a decimal and what is a fraction. Decimals and fractions are two different languages that are related that will show you numbers that are less than 1, pieces of numbers. So numbers that are less than 1 but greater than 0. So in this number line right here, this is where you will find your fractions and your decimals. Unless if it's a mixed number like 1 and 1/3, that's telling you have one whole plus a third of a piece of the number 1 to 2 here. Or if it was a number like 3 and 1/10, that you have a little bit more than 3 but not quite 4. So looking at that, we can convert any fraction to decimal and any decimal to fraction by understanding what they mean. So just a quick review of a fraction. A fraction has a numerator and a denominator, and these two numbers give you a lot of information. Look at the example of the fraction 1/3. The denominator tells me how many pieces I have to make a whole. So if this square is a whole, or representing the number 1, then we would have to divide this into 3 equal pieces. And that's the big thing there, equal. With all of these fractions and all of these decimals, these pieces of numbers are less or equal. They are equal. All of these pieces are equal. So we have 3, and the numerator is telling how many of those pieces do I have of the whole. So that's giving me 1/3, or 1 out of 3 pieces. It's an important concept to know and review. How many pieces make that one whole? If I had 3 of all those pieces shaded, you have one whole. So why are we talking about the stuff that you learned in first grade to review how to convert decimals to fractions? Well, I think if you understand that concept and can use this place value chart, you should be very successful today. Look at this problem here. A box filled with 1,000 cubes. Amy picks 4 cubes. How can you represent 4 out of 1,000 cubes? Anytime you see out of, you know it's a fraction or ratio. Like, same thing. Fractions and ratios are the same. So 4 out of 1,000, we know our total pieces to have the whole. So if this is a whole cube that represents the number 1, we would need 1,000 pieces to fit the 1. 1,000 of these pieces would give me 1 cube, or 1 whole unit. We're breaking units up into smaller pieces. And we have 4 of them, so that's my denominator is 1,000 and my numerator is 4. So 4 out of 1,000 is read as 4 thousandths. You think of the place value. If it was just 4 out of 100, it would be 4 hundredths. If it was 4 out of 10, it would be 4 tenths. You add that sound at the end. Hundredths, tenths, thousandths. And those are the 3 place values that you'll learn in 5th grade. So if we have 4 thousandths, you can go to your chart and you can put your 4 in the thousandths place, and you will know that it's 0.004, or 4 thousandths. Why? Let's ask ourselves why. Well, the decimal system is a little bit different than what you're used to with the whole numbers. And the reason why is that these names, tenths, hundreds, and thousands, they go up from left to right instead of right to left. Remember, it goes ones, tens, hundreds, thousands, 10,000, so forth. This is telling me, though, that these numbers are getting smaller. The pieces are getting smaller. And let's talk about why. So in 4 thousandths, you have these 4 tiny little pieces out of the 1,000 total pieces that would give you the number 1. If you had 1,000 out of 1,000, you would have 1. So the relationship about the relationship in each period goes times 10 as you go from left to right. And to prove that to you, let's look at this cube again. If I had 10 times 10 of this 4, I would have 40 cubes. 40 cubes would be 4, I'm going to do this in red, of the rods. Remember, the rods are the ones that go up and down like that. I would have 4 of them. And that would give me 4 pieces that are equal in number and value. How many of those rods do you need to make a cube? You would need 100 of them, right? Because there are 10 in each of the square. I'll put that in orange, which we know is hundreds blocks, but really when you're thinking of decimals, those are tenths because there are 10 of those slices in this one whole cube. So I would need 100 of these rods to fill up the entire cube, but 10 of these squares or flats to fill up the entire cube. So 4 thousandths times 10 would give you 400. So if I did this times 10, I would have 4 out of the 100 pieces I need, 4 of these rods. Do you see that? Let me repeat that again. If I times this by 10, I would have, so 4 here times 10 would give me these 4 rods, which would be 400ths, because these rods are 100 of those rods you need to make up this whole cube. If I would times these 4 rods times 4, so these 4 pieces times 4, I would have 4 tenths, or 4 total of those squares. So it's kind of like working backwards in your mind a little bit. If that's confusing you, that's okay. Sometimes it's a little bit easier if you just learn it, the process, before you learn the reason why and the place value. So let's look at the process here. This is a place value decimal chart. You could draw this very easy on a piece of paper. Really all you have to do is make a couple T-charts, and then you know the tenths, hundreds, and thousandths. This will help you write decimals, read decimals, and then write fractions. Let's look here how we could do that. Let's practice first with reading some of our fractions. Some of our decimals. So if I had this decimal right here, you read the number to the right of the decimal place, and then you say the period. This is 2 tenths. What if I tried this one? We would say that's 2 hundredths. What if I had this one? We would read this one as the numbers 12 thousandths. How do I represent 12 thousandths as a fraction? Well, you just said it. It's that easy. 12 thousandths. Or back to the other example I had there. 2 hundredths would be just 2 out of 100, 2 hundredths. What if you have some of the trickier ones, like, say, this one? That one is read as 30 is my number that I can see, 30 thousandths, right? 30 thousandths. If I had 30 of those little cubes, and there's 10 of these little cubes that make up a rod. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I had 30 of them, watch this magic. How many groups of hundreds do I have? If you look here, I have 3 hundreds. You know, you say, well, why is that not 3 tens, Mr. Hoffman? That's how I've done it in my brain all of these years going for place value. Well, when you're looking at the decimal representation, remember that those rods are hundreds, because if we thought of decimals in the thousands, because this period here is the thousands, that means that we broke this cube, this one hole, into 1,000 little pieces. Remember, we did that into 1,000 little pieces. This period is 1,000, so 1,000 would be 1 cube. 1,000 would be 1 cube. Well, I have 30,000s, so 30,000s regrouped would give me 3 rods. 3 rods would be my hundreds, because the rods, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are in each one here. That's 10 in there. There's 10 groups of 10. So that the rods are my hundreds, and the flat or the square piece, you know what it looks like, just imagine it for time's sake, is my tenths, because there are 10 of those square pieces to make the thousands. So that is why the place value is represented that way, to show you, because the relationship for these numbers are that when you go this way, the number is getting smaller. It's times 1/10, or really just divided by 10. That is not division, that's addition. But when you go this way, you are timesing by 10. So if I times that by 10, my 30 hundredths, you would know that 30 hundredths, I'm going to see how, 1 second, sorry, I'm going to make sure I say this correctly for you so I don't confuse you. We know that 3 hundredths divided by 10 would give me, if I took these 3 hundredths and I divided them each into 10, would give me 30 thousandths. See how I have 3 groups here? 1 group, 2 group, 3 groups. If I split these 3 holes here, these 3 groups into 10 pieces like I did here, I would have 30 thousandths. 3 hundredths and 30 thousandths are equal, and I proved it right there for you. The yellow lines that I highlighted are your hundredths groups, and if we split that or divided those into 10, and we did that by creating 10 little squares here, you would have 30 thousandths. They are equal. And a lot of times you can just drop that number and just rewrite it as 3 hundredths. So that's how we make it go from decimal to fraction. To make it go from fraction to decimal is a lot easier. What if I add like 32 out of 100? Ignore your denominator and write your numerator, 32. 0.32 is 32 hundredths. What if I had 150 out of 1,000? And all of these denominators are always going to be 100, 1,000, 10. All of them are going to be powers of 10, because we're in a base 10 system. 150 out of 1,000 would be 0.150. 150 thousandths. 150 thousandths. The last thing I want you to learn is when you have a whole number, so a number left of the decimal point, and a decimal, numbers right of the decimal point, how do you read it? So say I have the famous number 3.14 or pi. That is read as 3, and then you say and, because it's a little piece. 3 and then you read it the way you would normally do it. 14 hundredths. So today, my recommendation for you is if you're struggling with this, is to write that place value chart, and that'll help you solve the ones that you're doing. It's a simple conversion. Good luck, mathematicians.